When determining the minimum size of an underground service lateral for a copper-clad aluminum single-branch circuit serving a controlled water heater, the primary consideration is the ampacity of the wire. Ampacity refers to the current carrying capacity of a conductor, typically measured in amps. The National Electrical Code (NEC) provides guidelines for selecting the appropriate wire size based on the load it will carry and the conditions under which it will operate. The NEC specifies minimum conductor sizes for various applications, taking into account factors such as insulation type, ambient temperature, and the number of current carrying conductors in a raceway or cable. For a single branch circuit serving a controlled water heater, the first step is to determine the load demand of the water heater. This information is usually found on the appliance's nameplate, which lists the voltage, wattage, and amperage requirements. Once the load demand is known, the appropriate wire size can be selected from the NEC tables. It is important to note that copper-clad aluminum conductors have a lower ampacity than copper conductors of the same size. Therefore, it is crucial to use the ampacity values specifically listed for copper-clad aluminum in the NEC tables. The NEC Table 310.15. The 16 provides ampacity ratings for conductors rated 0 to 2000 volts, 60 degrees Celsius to 90 degrees Celsius in free air. For underground installations, the NEC also requires that conductors be suitable for direct burial or installed in a raceway approved for underground use. Direct burial conductors must be listed as such and have a moisture-resistant insulation. If a raceway is used, it must be made of a material that is resistant to corrosion and physical damage. In addition to ampacity, the NEC also specifies minimum conductor sizes for service entrance conductors based on the overall load of the dwelling. These requirements are found in NEC Article 230. When sizing service entrance conductors, it is important to consider all of the loads served by the service, including lighting, appliances, and heating and cooling equipment. For a single branch circuit serving a controlled water heater, a common minimum size for copper-clad aluminum conductors is #10 American wire gauge (AWK). However, it is important to verify this with the NEC and the specific requirements of the local electrical code. It is also important to consider voltage drop when selecting the wire size. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances to operate inefficiently or not at all. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the length of the conductor, the current it will carry, and the resistance of the conductor per unit length. The NEC provides tables with resistance values for various conductor sizes and materials. If the calculated voltage drop exceeds the recommended limits, you may need to increase the size of the conductor. In addition to the NEC, local electrical codes may have additional requirements for underground service laterals. It is important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes. When installing an underground service lateral, it is important to follow all safety precautions. This includes energizing the circuit before working on it, wearing appropriate personal protective equipment, and using tools that are rated for the voltage being worked on. It is also important to properly ground the service lateral to protect against electrical shock. Grounding is the process of connecting the electrical system to the earth, which provides a low resistance path for fault current to flow back to the source. This helps to trip circuit breakers or fuses and prevent electrical shock. The NEC specifies the requirements for grounding electrical systems in Article 250. In addition to grounding, it is also important to protect the service lateral from physical damage. This can be done by installing it in a conduit or by burying it at a sufficient depth. The NEC specifies minimum burial depths for underground service laterals in Table 300.5. The depth depends on the voltage of the circuit and the type of soil. When backfilling the trench, it is important to use clean, non-abrasive material to avoid damaging the conductors or conduit. The backfill should be compacted to prevent settling and to provide support for the conductors. After the service lateral is installed, it should be inspected and tested to ensure that it is working properly. This includes checking the voltage and current at the water heater, as well as testing the grounding system. If any problems are found, they should be corrected before the water heater is put into service. In summary, when determining the minimum size of an underground service lateral for a copper-clad aluminum single-branch circuit serving a controlled water heater, consider the following factors. Firstly, determine the load demand of the water heater. Secondly, select the appropriate wire size from the NEC tables, taking into account the ampacity of copper-clad aluminum conductors. Thirdly, ensure that the conductors are suitable for direct burial or installed in a raceway approved for underground use. Fourthly, consider voltage drop and increase the wire size if necessary. Fifthly, comply with all applicable codes and regulations. Sixthly, follow all safety precautions. Seventhly, properly ground the service lateral. Eighthly, protect the service lateral from physical damage. Ninthly, inspect and test the service lateral after installation. Finally, the correct American wire gauge size is #10 AWG. Remember to always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements. It's also crucial to consult with a qualified electrician for any electrical work to ensure safety and compliance.